Question 8 of Mock A, and it's a CVAT question for the first part, and it becomes a sort of circular motion one at the end. So there's a little excerpt about the Lockheed L-1011. It does require some information here. Top speed of 270. Get to that speed in 3/4 of a minute. So the time for acceleration is 3/4 of a minute is 45 seconds. Maximum range of 7,000 kilometers. So the maximum range is 7 million meters. And the time to decelerate was 6 minutes, which is 360 seconds. So find the minimum time of climb between Boston and Dubrovnik. So just going to create a little chart or a velocity time diagram. Time spent for accelerating is 45, time spent decelerating is 360, and the time here is x. And this is 270. So we know that 7 million, the total distance, is the area of this, which is 1 half 45 by 270, plus 270x plus 1 half 360 by 270. So just write it again, it's 7 million. 45 by 270 over 2 is 6,075 plus 270x. And then 360 times 270 over 2 is 48,600. So what we get is 270x is, once we rearrange everything, 6945325. So once we divide that by 270, that's 2573. Now that's in seconds. So the total time in seconds is 45 plus 2. 723 plus 360 is 26128 seconds, which if we divide that by 60 and then by 60 again, we get it in hours, which is 7.26 hours. Now, 0.26 of an hour is 15 minutes. So this is about 7 hours, 15 minutes is the minimum travel time between those two cities. The L-1011 did carry 120,000 litres of fuel. They also required a 5,000 litres of fuel upon landing to account for any ground faults. Density of gas is 808 from the mass of fuel on board. So, density is mass over volume. So if we find the mass on its own, mass is just density by volume. Now, 1 cubic meter is 1,000 meters. So if we get 120,000 liters, it'll be 120 meters cubed. So the mass is 808 times 120 meters cubed. So the mass of the fuel is 96960 kilograms of fuel. The empty weight on L-1011 is 1,079,060 newtons, and the change in mass of the L-1011 in kilograms per minute. Okay, there's a bit of a mental question, but what you can say, uh, first off, actually, is we know that weight is mass by gravity. So the empty weight is that without fuel. So 1075060 over 9.8 is 109,700. So the actual empty mass is 109,700. Now, the mass of the start has this extra amount of fuel on it. So 109,700 plus 96960, 206,600. The mass of the end, well, it should have 500, so it's 109,700 plus 808 by, instead of 120, it's 5. So 808 times 5 is 4,040. Add that to 109,700, and you get 113,740. Therefore, the change in mass over the change in time is 206,600 minus 113,740. What about the time in minutes? Now, 7 hours is 420 minutes, so that's 435 minutes. And we just find out what that is. And the answer is 213 kilograms per minute. Which, if you think about it, it's changing by about 90,000 over this course, so it actually makes somewhat sense. The maximum weight of a similar plane, McDonnell's MT-11, is 280 tons, where 1 ton is 1,000 kilograms. You can turn out maximum velocity at 85, angle of 10 degrees, take the value of g to be 10. So, when a plane is banking, the lift force is perpendicular to the wings, and this is 10 degrees on here. So this is L, and this would be L cosine 10. That's actually the centripetal force. But we also have the weight downwards, which is 2,800,000. So my room is getting quite dark, so I'm actually just going to flick a light on. But while I'm doing that, you can think about how you might solve the problem, or if you have already solved the problem, good for you. So let's prepare for this. So, like with all circular motion questions, even like the previous, the question 6, I think it was, forces up equals forces down. So 2,800,000 is L times cos 10. So L is just 2,800,000 over cos 10. Cos of 10. Calculus only a spasm. Cos of 10 is 2,843,195 newtons. And then we have the centripetal force, so that'll be L times cos. Oh no, that's L sine. Hang on, oops. So the thing pointing it up is L cos. Oh no, that is L cos. What am I thinking? I just did my diagram the wrong way around. So actually, what that should be is that's 10. That's L cos 10. There's L sine 10. There we go. Then the inward force is, I'll just write it as L sine 10 is 280,000. I can't think. So 280,000. So 280 times 85 squared times R. So we have the 2,843,195 sine 10 divided by 280,000 times 85 squared. And I get a very small radius. That's my pen. Sine 10 is that, yeah. We get a very small radius. We get it as only 2.4 by 10 to the minus 4. Now, normally planes would turn a massive radius, but that seems incredibly small. That's like 240 micrometers or something mental. Okay. Yeah, okay, right, whatever. Find the time taken for the MB-11 to make 2 revolutions. So this is where we need omega, so we can do period for 1, and then we can find it for 2. So we know that the time period is 2 pi divided by omega. Now, omega we know is V over R, which is 85, divided by this 2.4 times 10 to the minus 4. It's 35,416. So this will actually be 4 pi, because we have 2 times 2 pi divided by this. We get, I don't know what happens with this question, but we get 3.5 times 10 to the minus 4 seconds. This is definitely not realistic at all, but okay. Find the straight angle at which the MD-11 stalls on a maximum takeoff weight. Stall is when the weight force exceeds that lift force. So, lift force, weight force is capable of 3,000 kilonewtons, which is 3,000,000,000. That's a right angle. So this is going to be L sine alpha, which is that. And then we have, that's 2,800,000. So if that happens, L sine alpha, which is 3 million, should be less than 28000. So sine alpha has to be less than 0, 14 over 15. So alpha has to be less than the sine inverse that, which is 69 degrees. Fuck. So the empty weight of an MD-11 is 128 tons. Find the maximum lift force of an empty MD-11 if the stall angle remains the same. So in this case, the weight force is actually 1,280,000. But we want still 3,000,000 sine alpha to be less than 1,800,000. So in this case, sine alpha has to be less than 3/5, which means alpha has to be less than 37. So, yes, the stall angle does change for weight. And that is the solution to question 8 of this Applied Maths Mock A.